Welcome to Study Loop.
So we are looking at non-homogeneous linear equations here, in particular the second order ones, which is a little tricky. In this problem, here we have the second derivative of y plus y is equal to so I'm going to use the method of variation of parameters. So the first step is going to be to solve the our auxiliary equation is going to be r squared plus 1 is equal to 0. R is basically equal to the second derivative. Sorry, so r squared would be equal to the second derivative of y on the left-hand side. So when we solve this for our equation here, we get r is equal to positive or negative I, because we're going to be taking the square root of negative 1. Now, we'll also notice that if we were to solve the quadratic formula here, the negative, the expression under the square root, the b squared minus 4ac, would be less than 0, because here b is 0, so that gets knocked out, so we just have minus 4ac, where both a and c are positive. So this means that our solution will have the form y power of alpha x times c1 c2 sine theta x. And in our case, it's going to be c1 times cosine x plus c2 sine x. Now we want to use variation of parameters to look at a particular solution, which means when we have constants here, we need to make sure in the fractions. So we're looking at one two so we need to find the second derivative of this particular solution. First derivative would be y times minus plus that being added together will equal 0. So minus e1 of x for the first derivative of our particular solution. So we take the derivative now. U2 prime minus U2 sine of x minus U1 prime times sine of x minus U1 cosine of x. So if we substitute that into our equation, y double prime of our particular solution plus y prime secant squared, which is also 1 over cosine squared, right? So I'll write it that way. Since our solutions have cosines in them, it'll be easier for simplifying. So we get, when we substitute these things in and do a little simplifying, we end up with u2 prime times cosine of x minus u1 prime times sine of x is equal to 1 over cosine squared x. So now we have a system of equations we can solve. So we have u2 prime cosine of x minus u1 prime sine of x is equal to 1 over cosine squared. We also have u1 prime cosine of x plus u2 prime sine of x equals 0. So we're going to solve this to find u1 and u2. From the second equation, we can just get that u1 prime is equal to negative u2 prime times sine of x over cosine of x. If we substitute that into the first equation, then we get u2 prime cosine of x plus u2 prime sine of squared x over cosine of x is equal to 1 over cosine squared of x. So we can multiply the first expression by cosine over cosine so that it's all everything's over cosine of x then. Okay, which means that we can multiply both sides by cosine of x. That gets rid of the square on the right-hand side. We can also bundle up what's on the right-hand side here to be the derivative of u2 multiplied by cosine squared plus sine squared. Right, which is just going to be equal to 1. So what we end up with is derivative of u2 is equal to 1 over cosine of x. We can plug that into we had for u1 of prime. To get that is going to be equal to negative. So that was sine x over cosine of x times 1 over cosine of x. We'll have negative sine of x over cosine squared of x. So now we want to integrate these. Okay, so if we integrate u2 prime, so u2 is going to be equal to the integral of 1 over cosine of x, which is equal to the integral of secant of x. And this is equal to ln of secant of x plus tangent of x. I think it was in chapter 7 that you see this. So if you're wondering how that worked out, go there. I'm going to do the same thing for u1. Sine of x over cosine squared of x. If you do a substitution, where you let cosine of x be, so we'll just say cosine of x is equal to w. Then, of course, sine of x, negative sine of x becomes dw. And this integral is, of course, I missed the negative up front there. And so this integral ends up being just 1 over w squared dw, which we know how to solve. Right, so that's just going to be equal to negative 1 over w, which means that u1 is equal to negative 1 over cosine of x. So if we substitute this in to our particular solution, we get negative 1 plus the natural log of secant of x plus tangent of x times sine of x. And therefore, the general solution is c1 times sine of x minus 1 plus natural log of secant of x plus tangent of x times sine of x.